Hi everyone! For this video, we're going to discuss the different theorems of limits of a function. So let's start with Theorem 1. Theorem 1 states that the limit of a constant is itself. So if k is a constant and you're asked to find the limit of that constant as x approaches a certain number c, the answer is the constant itself. So as an example, let's have the limit of 3 as x approaches 2. The answer is 3. Because 3 is a constant, so the limit of a constant is itself 3. Another example, let's have limit of 2/3 as x approaches 0. The answer is 2/3. Last example, the limit of -4 as x approaches 5. So again, -4 is a constant. So by Theorem 1, the answer or the limit is the constant itself, which is -4. Now let's go to Theorem number 2. Theorem number 2 states that the limit of x as x approaches c is equal to c. So as an example, we can show limit of x as x approaches 5. The answer is 5. So the limit of x as it approaches c, which is 5, the answer is 5. Okay? Another example, the limit of x as x approaches -2 is equal to -2. And also another example, limit of x as x approaches 1/2 is equal to 1/2. So that's theorem number 2. Next is theorem number 3. It's called the constant multiple theorem or the constant multiple law, which states that the limit of a constant multiple of a function is equal to the product of the constant with the limit of the function. So that's limit of k, our constant, times f of x as x approaches c is equal to the constant k times the limit of the function as x approaches c. So to give us an example, so we can have, let's say, limit of 7x as x approaches 2. So to apply the constant multiple theorem number 3, so this means it's 7 times the limit of x as x approaches 2. So it's 7 times, what's the limit of x as x approaches 2? So we can use our previous theorem. So this will be equal to 2. So the answer is 14. Okay. Another example, let's have the limit of 8x as x approaches 4. So we can write this as 8, the constant, times the limit of x as x approaches 4. So it's 8 times, and the answer here is 4. So 8 times 4 is 32. Let's have another example. Let's have the limit of 3x plus 5 as x approaches negative 2. So we can break this down into 2 as limit of 3x as x approaches negative 2 plus limit of 5 as x approaches negative 2. So for the first limit rather, we can apply theorem 3. So this would be 3 times the limit of x as x approaches negative 2 plus the limit of 5 as x approaches negative 2. Okay, so let's move here. So this would be 3 times, so here, this would be, sorry, that's negative 2. Okay, so 3 times negative 2 plus the limit of 5, constant, theorem, so that would be 5. So 3 times negative 2 is negative 6 plus 5. So the answer is negative 1. For theorem number 4, it's the sum and difference theorem. It states that the limit of the sum of two functions is equal to the sum of the limits of each function. Or if it's the difference, so the limit of the difference of two functions equals the difference of the limits of each function. Okay, so let's have an example. Actually, this is a similar example from our previous example that we solved for theorem number 3 when we broke down two terms. So let's have this. The limit of 2x plus 3 as x approaches 2. So it means we'll get the limit of each function. So first function is 2x as x approaches 2. And the next term is the limit of 3 as x approaches 2. And limit of 2x, we'll use the theorem number 3. So we'll do 2 times the limit of x as x approaches 2 plus limit of 3, constant theorem, as x approaches 2. So we know the answers here. So 2 times, the answer here is 2 plus, and here we know the answer is 3. So 2 times 2 is 4 plus 3. Therefore, the answer is 7 for the limit of 2x plus 3 as x approaches 2. Let's have another example, but this time using difference. So let's have the limit of 4x minus 2 as x approaches negative 5. So again, we can break this down into two limits. So we have the limit of 4x as x approaches negative 5 plus the limit of negative 2 as x approaches negative 5. Okay, and for the first limit, let's apply theorem number 3, the constant multiple theorem. So 4 times the limit of x as x approaches negative 5 plus the limit of negative 2 as x approaches negative 5. So 4 times, we know this, the answer here, the limit of x as x approaches negative 5 is negative 5. And the second one is a constant theorem. So limit of negative 2 as x approaches negative 5 is negative 2. So 4 times negative 5 is negative 20 plus negative 2. So negative 20 plus negative 2 is negative 22. So that's the answer for the limit of 4x minus 2 as x approaches negative 5. Let's go now to theorem number 5, which is the multiplication theorem. It states that multiplying two limits that exist, it gives the same result as multiplying the functions and then finding the limit of the product. Okay, let's have an example to understand this further. Let's say we have limit of f of x is equal to 4 as x approaches c, and then we have limit of g of x equals negative 5 as x approaches c. So if we get the product of f of x and g of x as x approaches c, so this would be just 4 times negative 5, and that is equal to negative 20. Let's have another example. Let's have the limit of 4 times 3x plus 2 as x approaches 2. So we have the limit of 4 as x approaches 2 times the limit of 3x plus 2 as x approaches 2. So for this one, this is a constant theorem, so the answer here is 4. So 4 times the limit of, then we can break this down, of 3x as x approaches 2 plus the limit of 2 as x approaches 2. Okay, so there is, let's do that. So 4 times, so this one we apply the multiple theorem. So this will be 3 times the limit of x as x approaches 2 plus, okay, limit of 2 as x approaches 2. Okay, so 4 times 3 times, what's the answer here? Limit of x as x approaches 2. Yes, that's 2 plus here constant theorem, limit of 2 as x approaches 2 is 2. Okay, let's simplify over here. So we'll have 4 equals 4 times 3 times 2 is 6 plus 2. So 4 times 6 plus 2 is 8. So 4 times 8 is 32. So that's the answer. We'll have more of the other theorems in our next video. Thank you. Bye.